against with all the fingerprint we found at the crime scene. Okay, this is called your one-to-one comparison we are doing, and such type of your systems are called identification systems. That means whatever the fingerprint we have found at the crime scene, that we are going to compare who is that person against with all n number of your available criminal data. But whereas in your other based your attendance system, okay, there we are giving, that means already you know that, okay, you are giving your information and you are claiming that, okay, I am so and so person. Okay, that means these are your two different types of your identity systems that maybe, okay, we may come across in your daily life, either identification or verification. Okay, obviously the verification will be simple. Since it is one-to-one comparison, it will be very fast. But when you're going for your identification, okay, there we have to compare against with your lot of your samples. Okay, that how we can improve the performance of your identification systems. Okay, we need fast identification of the person with that biometric. But if you have taken any general biometric system, that may be either identification or verification based biometric systems, okay, the common process, general process in recognizing a person is, okay, first we'll acquire the sample, whatever the biometric, that may be iris or that may be fingerprint or that may be palm print or retina or whatever it may be, okay, the signature. First you have to acquire that particular sample from using your different sensors. Okay, we have the different types of your sensors are there. These sensors will make a difference, okay, when you are acquiring the sample. Okay, that means depending upon the quality of your sensor, the quality of the image or the sample which you are acquiring will also depends. Okay, and once we have acquired your sample, okay, directly these biometric sample we cannot compare against with whatever the biometric samples which are in your database. Okay, that means when you are acquiring this data, okay, a lot of the noise, that means in your on the sensor there may be dust particles will be there. When you are capturing your image, okay, your lighting conditions, in what direction you have captured the face image. Okay, these are all your different things that will affect the biometric sample you have collected. That means what we have to remove the noise which is present on the biometric sample. That means when you are acquiring the sample from your sensors, the dust particle, the environment conditions, okay, will add a noise to the sample we have captured, that you have to eliminate. At the same time, for example, if you have considered the fingerprint, okay, when you have captured your fingerprint, okay, that means when you're placing the finger on your sensor, okay, the sensor part cannot be completely captures the finger. Okay, other than this finger, there may be some other backward area will be there. Okay, you have to segment whatever the part from which we want to recognize the person. Okay, that you have to segment. Other areas, background areas, you have to remove. At the same time, when you have the iris is there, okay, but you cannot directly capture your iris. You will capture your eye image. Okay, and from that eye image, whatever your inner and outer pupil regions are there, between those, whatever the area is there in your eye image, that will be your iris. You have to extract that iris. Okay, that means whatever the biometric sample you have acquired from your sensor, okay, that you have to perform. That means you have to perform some pre-processing. You have to perform some pre-processing in such a way that you have to eliminate your noise and you have to segment unwanted area from that particular biometric sample. Okay, and once we have pre-processed that particular iris or biometric or any biometric sample, okay, then from those biometric sample you have to extract the features which are the distinguishable from any other person. Okay, that means those features we have to extract, and these features you have to use while you are authenticating that particular person. Okay, that means we may have the different feature extractors will be there depending upon the biometric sample which you are using. either iris or the finger. For each and every biometric sample, there will be different unique features will be there, and those unique features we can extract by using different feature extraction methods. Okay. But initially, okay, when you're going for either identification or verification, first you have to enroll your biometric sample in your database. Like if you're when you're going for your Aadhaar registration, okay, you are giving all your complete details, and then you are giving your finger, your all the four fingers, your thumb and your iris. Okay, they are capturing and they are storing with your details. That is called enrollment phase. Okay. And after that, okay, when you are going for your climbing, I am so and so person, okay, either identification or verification, the same process will be continued. You have to acquire the sample, you have to pre-process, and you have to extract the features. Okay, once we have extracted the features, once we have extracted your the features, then here the template will be generated. Okay, here the template will be biometric template will be generated. Okay, and these template we are storing in your database, and while in your verification or identification system, whatever the template we are getting, this will be compared against with your database. Okay, once this have been matched, then we can give either the person is genuine, or based on this we can give the person is imposter. Okay. This is a general biometric system, okay, which we can see. For example, if you observe that I have given the fingerprint pre-processing. Okay, this is your general fingerprint image which you are giving, okay, which will capture from your the sensor. Okay, and in general, okay, and these are all your different steps that may involve your fingerprint pre-processing. Okay, and we have to normalize your image, since whatever the image we have captured, it that may be, okay, the contrast values may be in your different ranges you have to normalize. Okay, and you have to segment unwanted area. If you observe that, okay, this is some gray part is there. Okay, and this gray part is not a part of your fingerprint image. Okay, that you have to segment, and you have to get only this fingerprint. Okay, and then, okay, we have to identify, okay, that for example, if you observe that in your fingerprint, okay, we have the different lines will be there, and these lines, okay, these lines we can extract, what is the orientation of these lines. Okay, what is the orientation of these lines. Okay, and these lines we have to extract. Okay, and once we have done this orientation and frequency and rich filtering, and then you have to go for your binarization. We have to get only the binary image, and then each and every line width will be your more than one pixels, since all the images will be in your pixels only. Okay, and each line width may be of your more than 1 pixel. But to extract these line features, okay, you have to bring the line width to your the single pixel. That is called thinning process. Okay, once we have performed this pre-processing, then this fingerprint is ready for your feature extraction. Okay, like that. Like if you have taken your iris, okay, iris means will completely iris database, or where we'll get only eye images only. From this eye image, you have to extract your the iris part. Okay, that means we have to localize. We have to, for example, if this is your eye image which you have captured, okay, and we need to get only this area. Okay, we have to get only this between these two circles, whatever the area is there, that will be our iris. Okay, that's why we have to detect your edges of this complete eye image. Then you have to segment all this, and you have to, during the segmentation, we'll get only the iris part. Okay, and if you observe that the eye image, the iris part of this, okay, eye image from each, if you have gathered from your all the different people, okay, that may be different sizes. Okay, the eye image or your iris size are in different sizes from person to person. Okay, but for your matching purpose, okay, if the iris image which you're extracting is of different sizes, it will be difficult for your matching. Okay, that's why you'll normalize. Okay, we can use, for example, if this is, okay, I can take your the 20 pixels. Okay, I can take your 240 degrees and I can, okay, normalize. I can bring to your a template. This is called your iris template. Whatever the iris image you have extracted, have taken the width of your 20 pixels and the degree of your 240. I can extract that and I can save it like this. And this is my iris template which I have extracted. This is called normalization. Once I have normalized, I will increase the quality of this image with the enhancement. With your enhancement, then we'll get your the pre-processed iris. This is different from your one biometric try to your other biometric try. Okay, once we have extracted I pre-processed iris, then from this pre-processed iris, we can extract your the features. Okay, and these features may be different. For example, if you have taken your fingerprint, okay, and here we have the different features from the fingerprint, local features and the global features. Okay, in general, we'll go for your, okay. Otherwise, we can also call it as level 1 or level 2 or level 3 features. These are your different features that we can extract from your the fingerprint biometric. For example, if you observe that here we have a line is ending here. Okay. A line is here ended. This is the end point. This is called your ridge ending point. Ridge ending point. Okay. And if you observe that this is a point where the line has been divided into your 2 points, that is called ridge bifurcation. Okay, and here we have observed that the circle hole is there, and here the things are in your arc, and this is your the left side, the loop is there. Like that, we have the different features will be there in your fingerprint. Okay, we can extract any features from your fingerprint. For example, we can take your the minutiae features or the level 1 features. Okay, like your ridge ending, okay, ridge bifurcation, okay, isolated connective trifurcation point, crossing points. These are all your different features that we can extract. Okay, by using your crossing number method, by using your a crossing number method, we can extract your different minutiae points. Okay, and simply we have to take your 3 by 3 window. We have to take your 3 by 3 window. Whatever the fingerprint image we are taking, that is a completely a matrix. Okay, then we'll start from your a 3 by 3. We'll apply your 3 by 3 window, okay, on fingerprint image, okay, and we'll find out whether a P is a ridge ending point or a P is a bifurcation point or a trifurcation or the crossing point, that will identify. And then we'll consider this P, X and Y coordinates as a one minutiae feature, like this. If this is your the structure, okay, then we'll say that if, okay, and this point is your the bifurcation point, and if this is your structure, and we can say that this point is your the ridge ending point. Like that, we'll consider your the features and we'll extract those features. Okay, and once we have extracted your features, your template will be generated, and this template will be compared against with whatever the template we have given in the enrollment phase. Okay, and how we can match this. Okay, in previously we can use any distance based measures like your Euclidean distance in general. Otherwise, we can go for your Hamming distance if you are using your I mean, when you're going for iris-based feature extraction, when you're going for the polar feature extraction, polar-based values, then we can go for your Hamming distance. Okay, we can use any of your these distance measures. Okay, and once we have identified, for example, we have your climate identity is there. Okay, that means at the time of your authentication you are giving one. Okay, and we have a template that is at the time of your enrollment is there. You have to compare this. That means we are finding the distance between these two templates. Okay, and whatever the value we are getting, and this value, that means you will put some threshold value. If the threshold is greater than your, I mean, whatever the value we are getting after calculating the distance between these two, if it is greater than your threshold, then we'll say that there is a match. If it is less than the threshold, we can say that these two are not matched. That climate identity is the imposter person, not the right person. Like that we can use. Otherwise, we can go for your any type of your machine learning algorithm, the classifiers, either support vector missions or C4.5, any decision tree algorithms, or your Navi-based classifier. Okay, to recognize, to classify the person, climate identity is a genuine person or this one. Okay, simply already you know that. Okay, when you're taking your For example, for a particular person, we are collecting your 5 images. We are collecting your 5 images for the person one. Okay, and among those 5 images, one image you will use it for your the enrollment. The remaining 4 images, okay, will use it for your training, some 2 or 3 images, and remaining one image you will use it for your testing. Okay, that means for the enrollment, we'll use some, for training, we'll use some samples, and for testing purpose we can use some samples. Like that we can create your own database of your different features, whether they are belong to the person or not. Okay, based on their values, we can decide whether they have been classified or not. But this is a general system, it is going to happen. Okay, whatever your previous authentication systems are there, like your password or smart cards, okay, these are all we can, okay, that can be taken by any other person. Okay, we can crack your passwords, anything can happen. But you are saying your biometric is very secure. Okay, can we replace these biometric features or the characteristics anything else? Obviously we are seeing a lot of things, or in your recent movies also we have seen how we can break the systems which are based on these biometric systems. And nowadays in this picture, if you observe that, they have created artificial artificial eye images, and they are giving for your the campus. Okay, but can we change your biometric characteristics if a human being is there? Okay, can we change? Can we alter our fingerprint samples, or can we alter your palm print? Can we alter your iris? Okay, in general, it is not possible. At the same time, okay, if you are considering your twins, okay, if you are using your face-based biometric systems, okay, then what happens in case of your twins? Obviously, in most of your cases, okay, the twins, maximum your twins have a similar features. Okay, then obviously these are your different problems that you are getting. Other than this, okay, for example, if you are using your the face-based recognition systems, okay, and if you observe that we have the different here, while you are enrolling, your direction is different, and while you are climbing, your complete the pose is different. Okay, and the lightning conditions maybe at the time of your enrollment is different, when you are climbing is different. Okay, your expressions are different. That means when you are changing your expressions, obviously your facial features will different. Okay, and you may use your some other ornaments or your scarf and everything while you're enrolling, while you're capturing or climbing. Okay, at the same time when age is going on, okay, that means when you are at the age of your 15, your facial features may be different. When you're at the age of your 30, that may be different. When your age of your 50s is different. Okay, and there may be individual persons. Okay, there's some physical structures like your eye and how their hairstyle, and these will also makes your the difference between your the climate and the original persons. Okay, that means within the same person, within your same person, okay, the direction and the expressions, the environment, lighting conditions, and other factors, the age factors is also affecting when you are trying to authenticate yourself, when you're trying to say that you are the right person. Okay, at the same time, if two different persons which have the same features are there, then obviously they will be recognized as the same person. Okay, but we have a lot of your problems are there in your biometric systems. At the same time, nowadays, okay, everyone is trying to theft your fingerprint, your iris. Okay, and simply you're mimicking your I mean your fingerprint is very simple. Okay, you can take your simply a clay. Okay, we can use your some powder and we can capture on your some paper. Okay, and those papers we can cut and we can use in your on your sensor to recognize. At the same time, we can use your clay and we can create your simple a thin a layer of your fingerprint. Okay, we can create a lot of your fake fingerprints. At the same time, we can also create your different eye models, the fake eye models. Okay, we are getting your the prosthetic eyes which will be created. Okay, the paper printouts, okay, we can take it as your complete your eye image as of your paper print that we can claim it at the time of your authentication, or we can create a separate prosthetic eyes that we can place on your iris, and we'll try to recognize. These are all your different problems that may arise in your while you're using your biometric systems. Okay, and whatever the problems which you are getting, that means in all these biometric systems, we are using a single biometric trait, single biometric trait. Okay, when you are using the single biometric trait, we are getting all these problems. We are getting all these problems. Instead of that, okay, to avoid, okay, the problems which you are facing in your such type of your biometric systems, we can go for your multi biometric systems. That means whatever the intra-class variations, your spoofing problems, okay, and when the in case of your twins, we are not able to find out your whether they are who is that particular person when you're using your face-based biometric systems, and when you're capturing your data, there may be a lot of your the dust which is on your sensor will create a problem in capturing your the samples. These are all your problems that may be erased when you are using your uni model or the single trait for your authentication. And to overcome that, we can go for your multi-biometric systems. There are different types of your multi-biometric systems out there. Okay, there may be a multi-sensors. That means to avoid the problems with your sensors, okay, we can use your multiple sensors. We can capture the same fingerprint image from the different sensors, and whatever the features we are extracting from all these captured images from the different sensors, okay, we'll use and will form a single template which will use it for your authentication. Okay, like based on this, based if you have collected the sample from only single sensor, obviously we'll get a problem. Okay, those problems and those the dust particles are the some noise which have created problems in the template that you can avoid with whatever the other sensors, the other quality sensors which we have used to capture that fingerprint image, and that information we can use to generate your the standard template for your authentication. That is your multi-sensors. Next one is your multi-samples. Instead of your collecting the sample once, we'll collect your multiple fingerprint samples. For example, if you observe that while your biometric Aadhaar card registration, they have captured your the fingerprint multiple times. That is called multiple samples they have captured. Multiple samples they have captured, and whatever the features which we have extracted from all these multiple samples will match and will try to use while you're authenticating the system. That is one type of your multi-biometric system. And next one, we can use, for example, we can use your the thumb as a one fingerprint, and we can use your the little finger as another fingerprint. Like that, we can use your multiple fingerprints to identify the person. That is called multi-instances. I can use my left eye and I can use my right eye. Okay, I will capture. That means my left eye is completely different from your my right eye. If we have taken any human being, okay, for each and every one, the left eye is completely different from your right eye characteristics. Okay, each and every one has their unique characteristics are there. And we can capture your multiple instances, multiple fingers or multiple eyes. Okay, we can capture and we can use these to recognize your the person. Otherwise, on the same biometric trait, that means you have captured only single fingerprint, and we can use your multiple algorithms to extract your the features, Okay, for example, on your fingerprint, we have seen an example. We, we can extract the minutiae features. We can extract your the minutiae features. Okay, that is one type of your feature extraction. At the same time, the texture-based features also we can extract from your fingerprint image. And whatever the features we have extracted, either minutiae points, that is ridge ending or the bifurcation, or the texture feature which we have extracted from the same fingerprint image, we can use and we can combine and we can generate a new template for the authentication. And such types of your biometric systems are called multi-algorithm systems. And next one is your multiple biometric systems. Okay, those will use your different biometric traits. Okay, I can use my finger and iris, or I can use palm print and iris, or I can use face and iris. The different biometric traits we'll use. Okay, if two biometric traits have been satisfied, then only we'll give the authentication that the person is a right person. The person is your right person. But in all these things, okay, we are capturing your, that means whatever it may be, in the multiple sensor, algorithm, sample or instance or multiple biometrics. We are capturing your different biometric traits, okay, or the same biometric traits. We are getting your the different features. We may get your different features. But how we can combine these features, how we can combine this information which you are collecting from your different sample or instances of the traits, okay, to generate your the template for the matching, template for your matching. And this integration can be done, or the fusion can be done in different levels. Okay, that is either before classification or after classification we can do. Okay, before classification means, okay, while you're capturing your the biometric sample itself, while you're capturing your biometric sample itself, okay, whatever the sample we have captured from the sensor, and those samples we can combine. Okay, that is called sensor level fusion or sensor level integration. Otherwise, okay, once we have captured your biometric traits, we can extract the features from those pre-processed biometric traits, and whatever the features we have extracted, and these features we can combine. Okay, this is called feature level fusion. This is called feature level fusion. Otherwise, we can go for another class of another fusion called post classification. After classification, that means we have extracted the features and then we have compared against with the template which is in your database. The template which is in your database. We have performed your matching. And then after performing your matching, you'll get your matching score, how much it has been matched, how much it has been matched. Okay. For example, if you are going for your verification system, okay, that means Aadhaar based attendance system. Okay, we are comparing with your one-to-one. Okay, when you are comparing your the template in your database with your the climate template, okay, we'll get your the matching score. Okay, based on this score, we'll decide whether, I mean, that is called your whatever the score for your biometric trait 1 and whatever the score for your biometric trait 2, these two will combine and will generate a score, and based on that combined score will decide. That is called score level fusion. That is called score level fusion. But when you're going for the identification system, that means we have a trait is there. We are matched against with all n samples in your database. Okay. Then, okay, we cannot exactly give that it has been matched with this sample 3 or sample 1. We have the n samples are there. Then, okay, we'll give what is the score, what is the matching with the sample 1, what is your, how much it has been matched with your sample 2, how much it has been matched with your sample 3. Okay, based on that, okay, the how much, how extent it has been matched with these n samples will give your rank 1, 2, and 3. Okay, like that for the biometric trait 1 and second biometric also will give your, will perform individually the matching for the iris and the fingerprint from the same person, will individually match, will individually give your ranks, and will combine these ranks, will combine these ranks. That is called your rank level fusion. That means we'll do either score or rank level fusion. Okay, with this matching comments. And once it has been matched, okay, we'll give you a decision. That means we have taken your first biometric palm print. Okay, this palm print we have given okay, for matching, and we have decided that it has been matched. That is genuine user. And next one, we have taken multiple, another biometric is your iris. And we have extracted the features and we have performed your matching, and the decision is you're not matched. Okay, that means two biometrics are there. One biometric is matched, one biometric is not matched. Okay, then what is your the decision? Okay, when you're combining these two decisions, okay, we'll combine the decisions and we'll decide what is your output. That means whether you are going to decide they have been authenticated or not. That is called decision level fusion. That means whatever the information we are gathering from these multiple biometric traits by using the algorithms or samples or the instances, okay, we can combine in different levels. But among all these 4 levels, okay, pre-classification level has the most information, a rich information about your biometric traits, which can be used for your the better classification, better recognition power. Okay, among the sensor level, which since immediately when you have acquired your sample from the sensor, sensor may generate your noise and other environment conditions may create your add your other data to your sample. Sensor level fusion will not give any type, better level of your recognition accuracy even when you are going for your multi-biometric systems. But whereas the feature level integration or the feature level fusion will always generate your better accuracy since the features from your different biometric traits which have the more distinguished power between your the different biometrics of the different persons, but there is a lot of your the problems in this feature level fusion since if you have extracted the features from your the same biometric or multiple biometrics, there may be of your different domains, the feature space from your different biometrics or completely or different. Okay. For example, if I have used your multi-algorithm on the same biometric, I have taken single biometric fingerprint. I have extracted the minutia points, that is pixel points, and I have extracted your texture features. The texture features are completely different, and the pixels, the minutia points are completely different. These are your two different features which I have extracted from your same biometric tag. I want to go for multi-algorithmic system by combining in the feature level fusion. And the domain of your the texture features are completely different, and the domain of your minutia points other features are completely different. Okay, then obviously when there belongs to your two domains, one domain will obviously play a vital role in your matching. We may dominate in your the matching. Okay, that is a challenge in your feature level fusion. And next one, okay, if you are adding the two features, that means the minutia points and the texture features which we have extracted, when you have combined these two, obviously we'll get the more number of your features. Okay. It will create your curse of dimensionality problem. It will increase your more number of your features, and handling your multiple features will also create a problem, time consuming, space consuming problem. These are all your different features. And but okay, how these features are related, how these features from your different traits, the same trait or the different feature extraction algorithms have been related. And this will create a lot of your problems when you're going for example, I will give how we can integrate. Okay. I have created, which we have taken the iris image, for example. Okay, the iris image, for that iris image, I have extracted your the texture features by using your a log Gabber filter, 2D log Gabber filter, and another is 2D Gabber filter. These are two different filters which I have applied on my iris image. Okay. And my filter size is 3 by 4. My filter size is your 3 by 4. Okay, when I have extracted the Gabber features, it will generate. Okay, it will generate. This is my log Gabber features, and this is my Gabber features. And okay, each size is your 20 by 240. Okay, since my input iris size is at the time of normalization, I have given, for example, this is your iris. Okay, I have given this is 20, and I have taken 240 angle. 20 by 240 is my size, and it will generate here 3 by 4 filter size 2D Gabber features. Okay, since these two are your same domain, this is a Gabber, log Gabber, and 2D Gabber. They are belongs to same domain. Okay, then there will be homogeneous space, feature space from the log Gabber and 2D Gabber. That's why simply I have combined these two. Have combined these two directly. I have combined this, and I have generated this one. Okay. Then I have performed my horizontal sampling and vertical down sampling. Horizontal down sampling and the vertical down sampling. This is your horizontal, and then I have performed the vertical down sampling, and I got your only one. This is of size 20 by 240. Okay, this 20 by 240 I have converted into your a single one-dimensional array, a single one-dimensional. But while I am combining these two, okay, I am giving your the different weights. Since I had thought that the Gabber filter may extract your the best features when compared to your log Gabber. Then I will give the more weightage for your the 2D Gabber features, and when compared to this log Gabber. That means when I'm generating this LG, when I'm generating this LG, okay, I'm assigning your the weight factors for these two. I'm taking the weighted average of these two. I can take weighted average and normal average or the addition or the sub like that. I can use any type of here the fusion, and then I can generate my the template. This is one. Okay, for example, I have used the different. Okay, the same iris. Okay, I have applied the either Gabber features, anything, log Gabber atom, and I can also go for the HAR features. I can use HAR wavelet to extract here the features, phase features from that particular iris image. This is the texture features and the phase features. Different features are there. Thereof belongs to different domain spaces. Different domain spaces. Then how I can combine these two different domain spaces? It is not possible. Okay, then I have performed here the vertical and horizontal and vertical sampling, have converted to a normal vector. This is your 20 by 240. Down sampling I have performed either horizontal and vertical down sampling, and what are the 20 by 240 is there that I have converted into a single line. And whereas we have the hard features are there, I have normalized this to the same domain of your Gabber features, same domain of your Gabber, and this normalized features, okay, which we have taken, okay, and whatever the Gabber features we have taken, that also have normalized to the same range. For example, I have normalized these two features to the 0 1 range, 0 1 range, both har and okay, Gabber features, and then simply I have concatenated the Gabber features followed by har features, the Gabber features followed by har features. Here, if you observe that whatever the size, this is your template, this is your the template that has been generated after your the concatenation, feature level fusion of your the har and log Gabber features of your same iris, okay, and the size has been increased. Whereas in your previous one, the size is same. Okay, since they are of your homogeneous space, log Gabber and 2D Gabber, simply I have taken the average of these two, weighted average of these two, and the size is same. But here the size has been increased. Okay, that means these are the different issues which may come across, okay, which we have taken multi-algorithmic system. This is your iris image. I have increased the quality. We have different pre-processing steps. What are the images we got? Okay, this is your 20 by 240 iris image. Okay, the Gabber and log Gabber, and this is the combined feature. This is your the combined feature. Like that we can take. But whatever if you observe that in the second one, okay, where we have combined your har wavelet features and the Gabber features, the size of your template has been increased. Okay, then when the size is increased, then obviously it will occupy your more amount of your memory space, and it will take more amount of your time for the matching, especially in your identification systems. Okay, that's why we have to reduce the number of your features, okay, and which will be betterly recognize the biometric samples, the person. Okay, then obviously we have to go for your dimensional reduction. We have the different types of your dimensional reductions are there. We can go for either feature selection or feature extraction, feature selection or feature transformation. Okay, we can by using your transformation or selection, we can reduce the number of your features. We'll see one thing called your feature selection. Okay, in general, when you're going for your feature selections, we have the standard feature selection algorithms are there. What are those? Okay, which we'll see in your forward feature selection and backward feature selection. Okay, like that we have the different feature selection algorithms are there. Okay, and sequential forward feature selection, floating feature selection, and forward backward feature selection, sequential backward feature selection. These are your the general feature selection techniques. Okay, but these feature selection techniques will not work for your high dimensional data. When you have the large data sets are there, then these feature selections will not give you better results. But we are dealing with your biometric data. Okay, and if you observe your Aadhaar data set, whatever your sample biometric data we are considering, okay, we have the data set is of your very large, huge amount of your data is there. Okay, on this very huge amount of your databases, such type of your feature selection techniques will not give you better results. Okay, and a best way is we can use your evolutionary computation to select the important features important features from the last data sets, and why we can select these evolutionary computation algorithms. Okay. But when you're going for any basic feature selection algorithms like your sequential forward or backward selections, or the backward or forward selections, okay, there we need to assume, okay, whether they are linearly separable, non-linearly separable data, okay, and we need on what type of your data we are working, okay, and based on that we'll decide, okay, how to select. Based on that we have to decide, okay, and we may have your different conditions will be there, and all these conditions we have to adapt while you are selecting your features, and these are all the things that may not that are not possible in your normal feature selection algorithms. But in your evolutionary computation algorithms, there is no need to make any assumptions, and we can work on any type of your data. There is no need of your any that basic knowledge, domain knowledge. And yeah, if you're getting your multiple conditions or the constraints are there, and all these conditions we can easily handle in your evolutionary computation algorithms. Okay. And these are all your population-based algorithms. We can use any type of your population-based, the basic algorithms like your genetic, your particle swarm optimization, your ant colony optimization, artificial bee colony algorithm, or cuckoo search. These are all your different algorithms. We can use any of these algorithms, okay, as a feature selection mechanisms. Okay, we'll see one example. I'll just brief out what is cuckoo search, how we can adopt this cuckoo search for your feature selection. But if you observe that we have a lot of your algorithms are there, why you're going for the cuckoo search. Okay, and in this cuckoo search, okay, and we can go for your global convergence. It has been proved that the cuckoo search will satisfy the global convergence requirements, and it will guarantee the global convergence properties. Okay, even when you're going for your multimodal optimizations, okay, the PSO algorithm may converge prematurely to local optimum. Okay, but always the cuckoo search will converge to the global optimum only. Okay. At the same time, your cuckoo search has the two search capabilities, both local search and global search. Both can be performed by cuckoo search, and it can be controlled by the probability. It can be controlled by your probability. That means in cuckoo search, the local search is here. It is generally very intensive, which is about your 1/4 of your search time will spend for your local search. Remaining 3/4 of your search time it will spend on the global search. Okay. This property will allow that this complete your search space can be. That means all the possibilities can be. Such space means what are the possibilities for our solution, for our problem, and all the solutions can be explored, and we can efficiently we can identify the global and optimum the solution for your problem with your cuckoo search. Okay, another advantage is that, okay, in this cuckoo search, okay, it uses the levy flight or the levy process for the global search. Like in your PSO or in your ABC or in genetic algorithm, they will use your random walk. They will use the random walk or the random search. Okay, while they are searching for the solution in your search space. But whereas in your cuckoo search, okay, it uses levy flight or the levy process instead of your random walks. Okay, these levy flights they have the infinite mean and variance. With that, the cuckoo search can explore the complete search space more efficiently than the previous algorithms, which are based on the Gaussian process. The search is completely based on your Gaussian process. Okay, this advantage combined with the local and global search properties of the capabilities of the cuckoo search will always generate the efficient and optimal solution for the problem which you have taken. Okay, that's why, okay, cuckoo search is more optimum and the best results that we are getting the best results in most of the problems. Okay. And in general, it has been originated from the basic the breeding nature of your cuckoo species. Okay, how the cuckoo species they will lay the eggs. They will lay the eggs in your host nest. For example, basically the cuckoos will not host place their eggs in their nest. Okay, they will lay their eggs in other and birds' nest like For example, if you have taken your cuckoo, the cuckoo will lay the nest, egg on your the crow's nest. Okay. In general, okay, the basic nature of your cuckoo is the laying or the breeding nature, the breeding behavior of that cuckoo is they have to lay their eggs, and complete your breeding will be done by your other birds. Okay. That means if any other species, once they have laid the eggs, if other species has rejected and destroyed that particular egg, okay, then it will be completely destroyed. Okay, that means we have to identify. We have to identify. That means whatever the nest is there, okay, in that nest you have to place your egg. Okay, is it clear? That means they are parasitic cuckoos. They will imitate the other birds eggs. In general, okay, when you are placing your eggs on the other birds can easily recognize, okay, but they will mimic the the color of the other bird's egg, and they will try to put that egg in that particular nest. That is the, the speciality in your female cuckoos. Okay, and obviously, okay, this will reduce the probability of your eggs being detected by the other host bird, and this will decrease the probability of your destroying that particular egg. Okay, but once they have detected, it will destroy. But how we can adopt this complete your the cuckoo breeding behavior to our problem. Okay, that means you are saying that each cuckoo is laying some egg at a time, and it is placing in your other bird's nest. Okay, and we are identifying what is the quality of the nest, what is the quality of your nest. Okay, and this whether this is the best nest. Okay, then we'll use it for your the next generation. That means we'll place your, for example, when a female cuckoo wants to place an egg, we have the nest 1, nest 2, nest 3, which belongs to the three different birds. And you will pick up your the best nest, and you will try to lay the egg on the best nest. You will try to lay the egg on the best nest. Okay, that means the number of your available host nests 1, 2, 3, 4. These are fixed. Okay, but what is the best one that we have to identify? What is the probability of your picking up the best one? Okay, and how we can place that particular egg on that particular nest, and whether after placing this particular egg, okay, whether the bird will recognize the egg or not. If it is not recognized, then good. If it is recognized, that means after placing the new egg, if your solution is not good, you have to remove the egg. Means after placing your egg, if the other bird has identified your egg, then that egg will be destroyed. The egg will be destroyed. Okay, and once we have identified that, okay, then obviously we'll go for the next one. We'll go for the next step, the next to place the new egg. And how we are identifying the next one? By using the levy flight, we are going to move. The same behavior will be. Okay, in generate your initial population of your n number of your nests are there, random nests are there. These are our solutions. The population is your nest is your solution. Okay, then we have the different nests are there. Okay, here, okay, these are all your host bird and the cuckoo egg. The cuckoo egg is your the new one which we are adding to your the solution, which you are adding to your solution. By adding to this new one, okay, is the solution has been improved or not? Okay, the bird has recognized or not? If it is improved, we'll continue, otherwise we'll remove. Okay, once we have laid the egg, okay, we'll select randomly, and we'll identify whether you can proceed with the new egg or not. If you are proceeding, then good. If it is best one, if it is not best, we'll remove. This we'll select with the help of your levy flight. Okay, then for all the nests, okay, whatever the eggs are there, we'll compare whether they are fit in that host nest or not. If they are fit, we'll compare, we'll leave. The means we'll place, otherwise we'll leave. Okay, and this will repeat. This will repeat. Okay, until we found your the best one. Okay, And this is your simple one. But how we can adopt this cuckoo search to your feature selection? Initially, we have to take your population. We have to initially take your the population and we have to initialize. And then you have to identify the nest fitness, the quality of your nest. Once you identify the best nest, you have to change the solution with your, that means we have to lay the egg. That is your, we have to use your levy flight. And then you have to repeat after adding this egg, whether your nest is best one or not. Okay, again, you have to calculate your best one, the fitness value, the quality of the nest, and you have to change. If the quality is not good, with the help of your levy flight, we have to change your the quality. Okay, and then again you have to calculate your fitness. And once we have obtained your the required satisfied nest with the best solution, then you can terminate. Okay, but we have to initialize your solution. But here we are using the cuckoo search for your feature selection. That means what are my nest eggs, whatever the features I have taken from the biometric sample. What are the features I have taken from the biometric sample? If I have n number of features are there, all these n features will become n eggs in my nest. All these n features will become your n number of your eggs in my nest. Okay, then what is my problem is whether I have to select all these n features or not. Among these n features, what are best features, okay, with which we can recognize the person efficiently. We can recognize the person efficiently. That is my aim. Okay, selecting the best features. Okay, then in my nest, whether I have included the feature or not, whether I have included the feature or not. Okay, that I have to know. Okay, that means if I have included that feature or that egg which represents one feature in my biometric sample, okay, then I will put 1, otherwise I will put 0. 1 indicates that the feature has been added in the solution, and 0 indicates that the feature is not added in your solution. Like that, I will take your first initially the number of your nest. Okay, what is my population size? What is my initial number of your nest? I may take your 100 or 200 or 10, depending upon the population. Okay, I can take your different nest. Okay, in each nest size is your fixed. Why? Because my template size is fixed. My template size is your, for example, D. Okay, then I have to fix my population, each nest size. Each nest can hold only D number of your features, D number of your X, D number of your X. But in a particular nest, whether I have included that feature or not, that I'll give 1 or 0, 1 or 0. Okay, I have to consider your the different nests, and each nest will be initialized like this. Each nest will represent your one solution. Okay, and I can initialize directly, or I can use any type of your mechanism to initialize my nest, to initialize my population. Okay, once I have initialized your population, I have to estimate the quality of the nest. I have to estimate the quality of your nest. That means I have to estimate the quality of the solution, whether it is optimal solution or not. To estimate that, we have to use fitness function. Okay, we have designed some fitness function. Okay, which is suitable for our problem is I have designed a fitness function which is alpha, beta, and gamma. Okay, alpha indicates the accuracy of the biometric data based on selected features. For example, okay, in this we have selected. Okay, the feature 1 is selected, and the feature 4 and 5, your 6, okay, and 8. These are the features selected. Okay, from we have the database is there for the different persons biometric samples, and their features are there. From this database, okay, I will select feature 1, your 4, 5, 6, and 8, okay, 9, and these features I will take, and I will try to estimate what is the accuracy with these features, what is the accuracy of your system with these features, and that I am considering as the first parameter in my fitness function, first parameter in your fitness function. And next, another parameter is your beta. Okay, and this beta indicates that what is the impact of these selected features on your recognition, on the authentication. Okay, and that we have how many features have been selected, what is the total number of your samples available, and how many features are there originally in your database. And based on this, I'm calculating the impact of the selected features. The gamma is, okay, there may be whatever the features I have selected that may be best or that may not be best. Okay, whatever the remaining features are there, that may have more impact. That's why I have to give some contribution to the non-selected features also. There we have given the contribute, what is the impact of the non-selected features. Okay, how many features are not selected, what is your database size, and what is total number of features. Okay, and this we have considered, and we have estimated your the fitness of all the nests. Okay, based on that we'll consider your the best one, and we'll try to lay the egg. When you're laying your egg, you have to select how we can. Okay, and that we are using your, okay, whatever the new one. Okay, you are selecting the which is the best one, this is the old one, and we are using your, okay, the levy flight, okay, to change, that means to add the new egg, to add the new egg, to add your new egg. Okay, once we have used this one levy flight, again we'll apply the same. What is that? We have added the new population, we have changed this old one, and we have given generated your new, and for this new one we have calculate your fitness, and again we'll pick up which is not the best one. You'll try to again, okay, use the levy flight to change the solution, to change your the solution. Like that, you will repeat the process until we got the best result, until we got your the best result. Okay, here I have given some results for your some specific systems. Okay, multi-algorithm systems. On the same sample, in the same palm print sample, we have applied the two different algorithms for the feature extraction, and we have combined, and we have taken the two databases. Casio is one database, IIT Delhi palm print database. Okay, without feature selection, okay, we have the 10,000 features are there. After combining the palm print images extracted from the two algorithms. Okay, if we have applied feature level fusion, we got the 10,000 features, both your Casio database and IDDL database. But when you have applied your cuckoo's based feature selection, these 10,000 features have been reduced to two. Okay, 2,602 and 2,403. There is a drastic change or a reduction in the number of the features. That means there may be unwanted features that may not affect, should not have any effect on your recognition accuracy. All these will be eliminated. And if you observe that how much memory space is required to store your template of your 10,000 features, a template of your 2,413 features, a lot of your the memory space will be, okay, we can weigh, that means it will be used when you are using your 10,000 features, and obviously the recognition accuracy will also be increased. Like that, when you have developed a fingerprint based multi-algorithm system, okay, on different databases, FEC and Casio, and multi-algorithmic iris systems, when you are using your Gabber filter, 2D Gabber, and HAR filters, we can develop three different systems. Okay, we can use IIT Delhi Casio database. These are your the reduction sizes. Without feature selection, how many number of features are there, and after applying your feature selection, how many results are there. The same thing, what is your recognition accuracy, okay, without feature selection and after feature selection. These are your databases and their results. Okay, but just I have given one sample biometric system, okay, and multi-biometric systems, how we can address the problems which you are facing. Okay, and how we can adopt your the evolutionary techniques and machine learning algorithms in case of your biometric systems. Okay, but even though all these things, okay, whatever the biometric sample which you are considering, whether you are acquiring the sample from your the living person or not. Okay, that means that whatever sample we are acquiring, that is the original sample or not, that you have to. So that means if you are extracting by use of your paper or the, we can create your, I mean, silicon based your layer on your finger. Like we have the different types of your biometrics that we can acquire other than your original one. Okay, how we can detect whether you are acquiring from the living person or not. Okay, at the same time, your system has to reject when you're trying to authenticate based on some artificial parts. Okay, with at the same time we need to get the high accurate authentication results, high accurate authentication results. For example, in Andhra Pradesh, okay, in your APSI has released a one face recognition based your attendance system. Okay, when you have opened that face recognition based attendance system, they're accepting that means they will capture your image, okay, and they will ask to blink your eyes. If you are the living person, then you will try to blink, then only it will capture your image and it will recognize your the face and it will mark the attendance. That means we are using one way of your recognizing is your simply blinking your eyes to detect you are the living person, you are the living person. Like that, we have a different challenges to use when you're using your different biometrics. Okay, for example, when you're taking your fingerprint, we can consider what is the temperature and thermographical image of that particular fingerprint to recognize whether you are capturing this image from the living person or not. Like that, for each and every biometric, we have the different ways of your detecting whether we are capturing the image from the living object or not, living person or not. That is one area where we have to work now. Okay. At the same time, when the sensors will also make a influence on your biometric recognition. Okay. If you're not using a quality sensor, then obviously what are the sample we have captured that may not give the distinguishable features which can be which have a more effect on your recognition accuracy. Okay, we have to identify a good techniques, okay, to develop a qualitative sensors which can capture the more qualitative the biometric samples, which leads to the good biometric system accuracy or recognition accuracy. Okay, these are your different the possibilities where we can do the research on your biometrics. Okay, and I conclude this and thank you. If you have any queries, you can ask.
Thank you, ma'am. Dear participants, can anyhow please ask any queries regarding the topic? Do you have any queries? All right. I think it's time to propose a formal vote of thanks to our expert. Thank you, madam. Thank you so much for taking the time to speak in the conference. Your insights and perspectives were truly valuable, and we are all thoroughly engaged by your presentation, ma'am. It was a pleasure to have you with us. And so your passion for the topic biometric systems and the challenges, various domains really came through in your words, and we are all grateful for the knowledge and inspiration you shared with us. Your contribution to the event was invaluable. Again, thank you for your time and for sharing your expertise with us. And we hope to have the opportunity to work with you again in the future. Thank you, ma'am. Thank you once again.
Okay, thank you, sir. Thank you for giving this opportunity for our majors. Thank you.
Thank you very much. Well, participants, we'll catch you on 1:30 for the next session. Thank you, ma'am. By 1:30, we have a keynote on from University of Argentina. Please grab that opportunity. She's an international speaker, right? Thank you all.